Hello. In the training framework of TRINEFLEX, Training Unit 1, I'm going to talk about TRINEFLEX approach. So before explaining the approach, it's good to have an project overview. So TRINEFLEX focuses on industrial flexibility transformation with mainly three pillars here: energy flexibility, which is related to multi-energy integration; process flexibility, adapting the operations; and feedstock flexibility using alternative raw materials. The goal here is to increase resilience, reduce emissions, and enable circular production. The approach is to digital-driven transformation across the value chain. So let's talk in detail about the digital-driven transformation across the value chain, the approach that we followed in TRINEFLEX project. This image shows the approach that we followed in the TRINEFLEX project, starting with demo case objectives and then focusing on the digital requirements and analyzing them, and focusing on the digital retrofitting part and the data collection, storage, data analysis, and decision making. So there are certain iterative loops between certain stages of this approach. The methodology here is to focus in the sequence and also iterate when it's needed. We also have the tool developments that are focusing on these different stages. And the output from these different stages is also recorded as lessons learned for replicability in other industrial sectors. Yeah, the first stage of this approach is to understand the objectives of each demo case. So we have 5 demo cases, starting with Verallia, which is from glass industries in Italy. We have Rifial aluminum industry in Spain, Esamor wastewater treatment plant in Spain, Halcor from copper industry in Greece. We have ADAP from water industry in Greece. So each of these demo cases has objectives to be part of this project. So starting with Verallia, here the idea is to reduce energy amount required through digital twinning of the process and optimization simulations. So increasing efficiency, implementing electricity source instead of natural gas consumption. And then we have Refial, which is focusing on reducing energy consumption in the rotary furnace by optimizing the process and enabling its flexibility through digital retrofitting and digital twinning. And it also wants to evaluate the use of hydrogen as an alternative energy source by hydrogen generation and storage modeling based on experimental gas generation and composition data from aluminum salt slag recycling process. And then we have Zamor. The objective here is to reduce energy consumption, mainly through, again, a digital twinning of the process, increasing energy flexibility, and implementing the use of renewable energy. And then we have Halcor. The objectives are to acquire the monitoring insights, increasing equipment flexibility, availability, efficiency, and reliability, and maximizing the energy and feedstock flexibility. And for ADAP, enhancing energy efficiency, reducing the costs. After having the objectives from each demo case, the next stages are to analyze the digital requirements and digital retrofitting different assets to achieve the demo case objectives. The digital requirements analysis included understanding system needs by identifying the process constraints and flexibility potential, data availability and gaps, and control and optimization requirements. So through this analysis, digital retrofitting focused on upgrading existing assets with sensors, IoT devices, smart controllers, and other connectivity solutions. So during this digital retrofitting stage, several solutions were implemented, like real-time monitoring and edge cloud integration. The purpose of digital requirements analysis and digital retrofitting is to turn traditional plants into flexible data-driven systems. Once the digital retrofitting has been completed, now the time to build the data backbone. Here we have a current solution that collects data from all the demo cases. So this data is collected from equipments and processes, energy systems, and external sources. So this stage ensures data quality and standardization, scalable storage infrastructure, and prototypes were developed to allow demo cases to share data while maintaining data sovereignty, meaning the provider retains control over how their data is used after it is sent. Yeah, the next stages are data analysis and decision making. So once the data is available, the next step is to transform it into meaningful insights. This is achieved by applying advanced analytics and artificial intelligence along with predictive models and digital twins. These tools allow us to better understand system behavior and anticipate future conditions. In practice, this enables key use cases such as demand response optimization, improving process efficiency, and supporting feedstock switching strategies. The result is actionable intelligence that allows industries to operate more flexibly and efficiently. Building on these insights, this stage focuses on intelligent and automated control. Based on different stages, the tools were developed. So this is a list of tools for each demo case. So this is a list for the Veralia, Refial here, Examor here, Halcor here, and ADAP. So these tools are very much focused on the objectives of each demo case. And in parallel, we also have the transversal tools that are used across all these demo cases. This stage focuses on the lessons learned and replicability. One of the objectives of TRINEFLEX project is replicating the solutions. One is replicating in the same sectors as the demo cases in the project, and another one is to replicate the solutions in other sectors that are away from the demo cases. So here we focused on collecting all the information that's from all the stages and about the tools. So here we have a replicability study and how to implement and replicate it. So here we have the different results and which ones can be highly replicable and so on. So the idea here of the stage is to collect all this information to help us in replicating these developments from TRINEFLEX to the same sectors and also to the other sectors. Key takeaways from following the TRINEFLEX approach just explained. So the impact of TRINEFLEX here is to enable low carbon flexibility industry. So it combines digital transformation, energy system integration, circular economy principles. It provides scalable solutions for Europe's industrial transition. Thank you.